Hello, students. We are going to go over line segments, lesson 1.3 today. Here we go. We're going to get started. We have lesson 1.3 on line segments here. Of course, it doesn't want to work right away. There we go. So the main points are right at the beginning. A line segment is a measurable part of a line that consists of 2 points called endpoints and all of the points between them. The 2 endpoints are used to name the segments. So when we talk about a line segment, we are going to have a point. Maybe we call this point A. You're going to use a capital letter because it's a point, and we're going to have another point, and I can call this point B. Again, a capital letter because it's a point, and a line segment is the segment that connects the two of them. So it's right between them. It is a measurable part, so it has a distance to it. It's got those 2 points that are there. And all the points between them. So realize when you draw this line, that actually is a representation of every little point that's in here. Just remember that it's made up of a bunch of little points. And as soon as I draw all these, I'd have to overlap more and more. And that's how you form a line. The 2 endpoints are used to name it. So this segment could be called segment AB with a segment bar over it. Notice they use capital letters for both of those. Or I could call this segment BA. Other thing to know about line segments is that if I had a line that was drawn, and I'm going to use different letters, so I'll use C and D and E here, is a few things here is I could talk about and I could name segment CD. And if I name segment CD in this case, I am simply talking about, sorry, let me get my pen there. There we go. I am simply talking about this piece right here. Even though there is a line that's there, there's an E that's there. If I talk about segment CD, that tells you what part of that picture that I'm talking about. Okay. You know that for any 2 numbers, A and B, there's a real number n between A and B such that A is less than n, which is less than B. So it's just talking about that idea of even if you have the numbers 1 and 2, there is something that's between them. So for instance, like 1.3 is between them and lots of other things. This relationship also applies to points, and it's called betweenness of points. So we're going to talk about if I tell you that point C is between A and B and what that means. Okay. So if I give you this very first diagram up here again, ignoring this bottom part here, and say point C is between A and B, that does not mean that I can put C up here. That would not work. Okay. It does not mean that I could put C on the end. That would not work either. I have to put C somewhere between A and B. Now, it does not mean that it has to be the midpoint. Now, that would work. That is between it, but that does not have to be the case. So for the purpose of this, I almost always draw it not as a midpoint. So if I draw C there, this is the case. Point C is between A and B. And it's if and only if A, B, and C are collinear and the distance between A and C plus the distance between C and B. So the distance between A and C, that measure right there, plus the distance between C and B, that measure is equal to the distance between A and B. Biggest thing right there is that I will have students that think that if this is A, B, C, that C is between A and B, and we talk about it as the distance here plus the distance here is not going to be equal to that full distance that's there. So that's the difference in those. Okay. If we keep going on, then we're going to go through just a few examples here. And these examples this example is done in your book. The checks are not. So we'll kind of look at them there. But if you are finding the measure of xz in this case, I'm finding the distance between x and z. I have a distance. So if you have a distance that is given, and it's given here, that is telling me that that is the measure between the points on either side of it. So point X is on this side and point Y is on that side. And for this one, it's the measure between point Y and between point Z. So I would just simply do 11.3 plus 3.8, and I would add my numbers here, and I would get 15.1 centimeters for my final answer. Now, if you're asked to find the measure of DF here, this is just a little bit of extra practice with our fractions as well as what we're doing here. So we would do 2 7/10 plus we would do the 5 9/10 here, those 2 parts that add up equal to a whole. So that's something else you'll hear me say is that the part plus the part is equal to the whole. So the DF is the whole in this case. So I can add my 2 and 5 when you're doing fractions here, just a reminder, I can add my 2 and 5, they're whole numbers, and I can add my fractions because they have the same denominator. So that's going to be a 16/10. And since I have a whole here, I have another 1. This 16/10 is 1 and 6/10. So I'm going to add that to my 7. So that's going to become 8 and then I'm going to simplify my 6/10, divide both by 2. So that's going to be 8 3/5. So my final answer there would be that it would be 8 3/5 inches. Example 2 talks about finding measurements by subtracting. So just be careful when you look at stuff that, for instance, in this one, it's not part plus part equal the whole. That 13 3/4 is the whole here, and the 6 5/8 is the part. So I'm going to skip going through that one, but that's the idea that I want you to get from that one. Write and solve equations to find measurements. So this is where we're going to start to kind of work on our geometry concepts. Some of you will find this very easy. Some of you will struggle with this a bit more. Find the value of x and BC if, so we're going to find 2 different values, if B is between A and C. So I suggest, and I love drawing pictures, but I suggest drawing a picture in this case where B is between A and C. So I want a point A. I want a segment off of it. I want a point B somewhere next to it. And then I want C on the far end. Now, it does not matter where you put your B. If you want to put it dead in the center, that's fine. If you want to put it closer to C, totally up to you. We're not drawing this to scale. We're simply drawing it to give us an idea of what we have. And then it tells me AC. So a lot of people would take just the first number plus the second number equal to the last number. When you're trying to do part plus part equals whole, you're going to notice here that doesn't work. So I see the 4x minus 12. If I want to mark the measure of AC, I have to make like a little box from one to the other since they're not points next to each other. And I can mark that as 4x minus 12. And then I have AB, which was x units long. I can mark that between A and B, and BC, which was 2x plus 3 units long. And now I can kind of see where the part plus part equals whole comes from. And it's coming from here. So I'm going to do my x plus my 2x plus 3. So that's going to be a total of 3x plus 3 equal to, and then my whole is the 4x minus 12. Okay, that's going to get distracting. That's a kind of fun pen, but that's going to get distracting. So let's switch. Okay, so then solve my equation, subtract 3x from both sides. You end up with an x on this side minus 12 equal to 3. And I'm going to add my 12 to both sides. And that's going to give me my x value of 15. So it did ask me to solve for x, but it also asked me to solve for BC. So BC has a measurement of 2x plus 3. Put the x into the 15. So my BC is going to be 2 times 15 plus 3. And if you can do this in your head, that's fine. So then that's 30 plus 3. Getting too low on my writer here, which is then going to be 33. So that I know that my BC measurement is equal to 33 in this case. Now, units wise, there are no units in this problem, so you do not need units on your answer. Okay, so this last concept that they kind of talk about is that of if 2 geometric figures have exactly the same shape and size, then they are blank. 2 segments that have the same measure are blank. The word is congruent. We're going to use this word a lot in this chapter, in this semester, actually this entire year. So this would definitely be a good place to highlight something. We can highlight that word congruent. We have congruent segments as well. But we're going to talk about congruent in a lot of different ways. You really just need to understand what it is. But probably the basic definition is just same shape, same size. So you're not going to have a triangle and a circle be congruent to each other. You're not going to have a small triangle and a big triangle be congruent to each other. Those kind of things. So same shape, same size are the ideas to that. So congruent segments, you can kind of see what you have here. A lot of what we're going over here though is the symbols. So if you are drawing segments and you want to draw them congruent, you're going to put what we call these little slash marks on the diagram. So that's what you're seeing there. That you can put on that diagram. And then if you are trying to write congruences, you're going to use this congruent symbol, which is an equal sign with a squiggle on top. Now, I don't care which way your squiggle goes, as long as you've got that squiggle and it's not like 3 equal signs or something. Essentially, that congruent idea is that they're equal approximately, or it's not equal because those are measures, but it's congruent there. So it's read as is congruent to. So you would read this as segment AB is congruent to segment CD. Making sure that I read everything that's there. Yes, and every time that you know congruence, it does tell us that they have the same measure. So we will talk about this in terms of angles, in terms of segments. We will talk about some figures being congruent, but when we talk about segments, it does mean that they have the same measure. Use a consecutive number of tick marks for each pair of new ones. So what you're seeing here is that once you've used the single set and you have another thing in your diagram that's congruent, you would then use a double set. So this is the double tick marks is congruent to the double tick marks. The double is not congruent to the single. And then you can go on to triple and so on. If you get beyond that, I'll explain when we get there, but that's where we're at right now. You can use extra marks for congruences. Okay, so we get into problems like this. Find the value of x if q is between p and r. And it tells you your PQ, it's already labeled though, it tells you your QR, that's also labeled, and it tells you that PQ is congruent to QR. So what we really want to just make sure of in this case is that you understand that congruence does tell us equality. And so here we would simply set my PQ equal to my QR and say that 6x plus 20 is equal to 2 times x plus 6. We are going to talk about justifications a lot in this class and justifying your work. So that's where this comes into play, kind of one of our first times through that. But if you're going to justify what you know, PQ is equal to QR because we knew that PQ is congruent to QR. And so based on the definition of congruence, we know that they're equal. So definition of congruence allows us to say that they're equal to each other. And then you're able to do some substitution in this case. So that was our definition of congruence. Then you're able to do some substitution in this case to substitute in what we know. So we were told 6x plus 20 was equal to PQ. So we substituted that in for the PQ. And then our QR we knew was equal to 2 times the quantity of x plus 6. So we substituted that in. Now, if you are going to abbreviate substitution, do not do SUB because that is subtraction for us, or it's a confusion. So make sure you get to at least SUBS. I don't know why I always go to the T, but I do. So substitution is what we have there. Then we're going to start to solve. Now, the rest of these, and the reason I start with this is because these are all things that you guys have learned. So what you would ask yourself is, what did I do in this step to get to this step? And what you did is you distributed. So this is the distributive property that you used to get there. You distributed the 2. From this step down, you can see that what the person is doing is subtracting 2x from both sides. Now, most of you will write this as a minus 2x like this. What they did is rewrite the problem so you can see that's what they're doing there. So this is what is called the subtraction property. What the subtraction property says is that you can take an equation and subtract the same quantity from both sides of the equation. So if you just simply write subtraction here, that is not correct. Subtraction would be taking something like 15 minus 3. Or it'd be taking something like 6x minus 2x. But if you want to subtract something, the same quantity from both sides of an equation, that was your subtraction property that told you that you could do that. So we did that. Then this next step is just a simplify step. You're going to notice that a lot of the times when you're doing algebraic problems and you're having to justify, you'll have a simplify step in there because that's really just combining like terms, which is what you did here. So you took the 6x minus 2x, combined them to the 4x. You took the 2x minus 2x, combined them to 0. And so that's a simplification step there. Then you see a next step here. So if you look at 4x plus 20 equal to 12, think about what you would do. You'd probably subtract 20 from both sides, which is exactly what they did here. So that again is another subtraction property step. I know that they wrote it up here. I'm kind of giving you some different ideas here of what we're going to see later on. So that's how I'm going to write that, is just simply subtraction property. And then again, we're going to simplify for that one. So we just simply took the positive 20, negative 20, made 0 out of it, and 12 minus 20 to make negative 8. Okay, then you are going to divide. So that is what is called the division property. You're dividing both sides of the equation by the same quantity. So in this case by 4. And once we've divided by 4, we get x equal to negative 2. So that's another simplify step in that case. Okay, so that is a quick idea and a quick introduction into justifications, which we are going to start to be calling proofs of something. So we essentially just proved that if we know that PQ is congruent to QR and the other stuff that was given here, that we know that x is equal to negative 2. So equal versus congruent, lengths are equal, segments are congruent. So what I talk about when we get to this kind of stuff is that we are going to talk about that AB is equal to CD. So AB without the bar over it is read as the distance between A and B, or the measurement of AB. And same thing with CD there. If you put the bar on it, then you're talking about the physical segment AB, and that segment can't be equal because it doesn't have, you're not giving a measure there. So it can be congruent to something else. And so we mark it that way. So that's how you would mark those. Again, the reason that this has an equal sign is because the distance between A and B is a number, is represented by a number. So it can be equal to something else. And same thing with the CD. Okay. So what you are not going to do is one of those other two that's given. Now I say that you're going to make the mistake. I'm going to fix it, but we're all going to work together on that. And that's something that I am a pretty big stickler on, because if you want to use the shorthand, you've got to use it correctly. Otherwise we get to simply write out, and I'm not even going to write it right now because it takes too long. We would literally write out the distance between A and B is equal to the distance between C and D each time we wanted to say that. And here we would write segment AB is congruent to segment CD each time we wanted to write that. So use the shorthand correctly. I am a pretty big stickler on that. Check your answer. Sometimes solutions will result in negative segment lengths. If this occurs, review your work, either an error or there's no solution. So just remember that. Check your work as you go through it. I love that they give you your two things. Either you made an error, which is possible, or if you got a negative segment length. Now remember, a variable can be negative, but the segment length can't be negative.